We're in section 10.2, and we're talking about the sine and cosine ratio. So on Friday we talked about the tangent ratio, and we said that because we're dealing with a right triangle, and if we know that we have a 90-degree angle, it's a right triangle. So this is our 90-degree angle, and this is our other angle. As long as we know that we have the right angle and any other angle, that the ratios that we make with the sides are going to be the same no matter how big or small our triangle is, as long as we have a right angle and one other angle. That's what let us figure out the tangent ratio. For the tangent ratio, we used the opposite side and the adjacent side. And we didn't ever have to use the hypotenuse to calculate our tangent ratio, but we might have had to use the hypotenuse to find one of the other sides. So what we're going to do today is talk about a couple of ratios that do have to do with the hypotenuse of our right triangle. So I'm going to label the side here. So our side always talks about adjacent and opposite based on our angle. So this is our adjacent side. This is the opposite side, and the hypotenuse is always the hypotenuse. So those are our three sides of our right triangle. So we're going to define a couple of new ratios. The sine of A, or we write sine theta, is the opposite over the hypotenuse. And we're going to say that the cosine of A, or cosine theta, is the adjacent over the hypotenuse. So now we have all of our ratios for the different sides of the triangles, all our main ratios, with the different combinations. So the sine and the cosine are just a couple of different ratios that we can make with these triangles, because as long as we have a 90-degree angle and one other angle, we know that those ratios are going to be the same for any triangle that has a 90-degree angle and this other angle. And the way that we usually have a little phrase that we use to remember which sides of the triangle we make our ratios with: Sohcahtoa. So what Sohcahtoa tells us is that the sine of the angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. So this is how we can remember which sides go with which ratio, Sohcahtoa. And from here on out in math, you'll probably hear Sohcahtoa in just about every other math class you ever take, because trigonometry shows up in so many different places. So this will help us remember which sides of the triangle we use to make these ratios. And it's important to remember these are all ratios. We're making ratios out of the sides of a triangle. That's where the sine, the cosine, and the tangent of an angle come from. So questions on what sine and cosine of an angle are? So really what we're doing today is the same thing that we did on Friday. We're just using different sides of our triangle. There's really not much different that we're doing. We're just using different parts of our triangle. So let's look at a few examples. If we know the sides of the triangle, finding the ratios is really easy. All we have to do is write the ratio down. So here's our triangle. And here's our angle. And I'm going to make this a 3, 4, 5 triangle. And we want to find the sine, the cosine, and the tangents of theta. So let's do what we suggested on Friday and label the sides of our triangle. So for opposite, adjacent, or hypotenuse, here's our angle. This is going to be the adjacent side. 3, is that the opposite or the hypotenuse? Opposite, so that leaves this for the hypotenuse. So the sine of theta is the opposite over the hypotenuse. That's it. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is the opposite over the adjacent. So that's all there is to that kind of problem. If we know the sides of the triangle, all we have to do is write that ratio. I could turn this into a decimal. 3 divided by 5 is 0.6. 4 divided by 5 is 0.8. And 3 divided by 4 is 0.75. But this is a ratio. 3 divided by 5 is 0.6. 4 divided by 5 is 0.8. 3 divided by 4 is 0.75. So the sine, the cosine, and the tangent are just these ratios. Questions on that one? All right, we use our calculator with sine and cosine just like we did for tangent. We use the sine or cosine button to find the ratio if we have the angle. If we know the angle, we just use the sine or cosine button and the calculator will tell us the ratio. We use the inverse sine or the inverse cosine, the same way we did inverse tangent, to find the angle if we know the ratio. Just like we did for inverse tangent. So we'll do the inverse sine, inverse cosine, inverse tangent using these ratios to find our angle. So from this problem, we had sine theta is 0.6. That's what we figured out here. So theta is the inverse sine of 0.6. So I'm going to go to my calculator. And I'm going to do the inverse sine, which is right here, of 0.6. And I get 36.87 degrees. Sorry. The inverse sine of 0.6. So this gives me 36.87 0.87 degrees. I could also find the angle by, we know that the cosine of the angle is 0.8. So theta would be the inverse cosine of 0.8. I can plug that into my calculator. If we do everything right, I should get the same answer. The angle shouldn't change depending on whether I use the sine, the cosine, or the tangent. So I'm going to calculate the inverse cosine of 0.8. Inverse cosine, 0.8. And I get 38 or 36.87. Same answer. And I should get the same thing if I do the inverse tangent of 0.75. We said the tangent of the angle is 0.75. Plug that in, and I get the same angle for any way that I go to calculate. So to find the angle, we use the inverse of whatever ratio we were talking about. So all of these would be 36.87 degrees. So to find our angle, we use the inverse. And that's for all of the ratios. Inverse sine, inverse cosine, or inverse tangent, depending on which ratio we use. All right, questions on that part? So let's talk about solving problems. In math, that's what we want to do. We want to solve problems. So we'll write our steps like we did on Friday. Our steps really are the exact same as they were as the ones we talked about on Friday. We just have a couple of choices this time. So our steps are the same as before. We just have a couple of choices in a couple of different places. So our first step is to label the triangle. Label the opposite side, the adjacent side, and the hypotenuse. Here's where we have to make a choice. Decide which ratio to use. And we're going to decide based on what parts of the triangle we have. Do we have the opposite and the hypotenuse? Do we have the adjacent hypotenuse? So depending on which sides of the triangle we have, we decide which ratio to use. Once we decide which ratio to use, then we write an equation. But now we have three different equations that we could write, depending on which sides of the triangle we have. But the equations are always going to look the same. It's either going to be the sine of the angle equals, and if we have the opposite, I'm going to use a shorthand here, opposite over hypotenuse. If we have the adjacent and the hypotenuse, then we write the cosine of our angle equals the adjacent over the hypotenuse. And if we have the opposite and the adjacent, then we write the tangent of the angle equals the opposite over the adjacent. So we have three choices of equations that we can use. So we have to decide which ratio to use. When we decide which ratio, then we write the equation that goes with that ratio. Then we're going to solve for what we want. And then our last step is to use our calculator. So just like before, you just have to choose which ratio to use. So questions on our steps? If we follow these steps, we pick the right ratio, we'll get our problems right every time. All right, let's look at a couple of examples. So for the first example, we want to put a 12-foot support wire on a tree at a 30-degree angle from the ground. We want to know two things. One, we want to know how high up the tree we should attach it. And our second question is, how far from the tree do we attach it to the ground? So if the problem doesn't give you a picture, draw a picture. So here's my tree. And we want to put a 12-foot support wire, like so. So this is 12 feet. And let's call how high up the tree, let's call that H. And how far away from the tree, let's call that D. So the distance from the tree. And we're putting a big stake in the ground here. And we're putting this wire up because the wind blows. And it would blow the tree over if we didn't put a wire there. So we have two problems we need to solve. So let's do the first one. Now we want to label our triangle first. So let's figure out what sides we have. The 12-foot wire, is that the opposite, the adjacent, or the hypotenuse of our triangle? That's the hypotenuse. This is our 90-degree angle. And the problem I forgot to put, it tells us we have a 30-degree angle from the ground. So that's our 30-degree angle. 12 feet is always the hypotenuse. The long side is always the hypotenuse. H, is that the opposite or the adjacent side? Opposite. It's across the triangle from the 30-degree angle. So that leaves D for the adjacent side. So let's solve the first problem, the part one first. For the first part, we're trying to find H. We have the opposite and the hypotenuse. Which ratio tells us about the opposite and the hypotenuse? What is it? Sine. So I'm going to write sine 30 degrees equals the opposite, H, over the hypotenuse, 12. Now I can solve my equation. How do I get H by itself? How do I solve for H? Multiply both sides by 12. Move this over a little bit. And I get H equals 12 times sine 30 degrees. And I just plug this into my calculator just like this, 12 times the sine of 30 degrees. And I get that H equals 6 feet. So I need to attach this wire 6 feet up the tree. For the second part, we want to figure out D. So which ratio tells us about the adjacent and the hypotenuse? Cosine. Think Sohcahtoa. Cosine is adjacent over the hypotenuse. So I'm going to write cosine 30 degrees equals D over 12, the adjacent side over the hypotenuse. Go through the same steps here, multiply both sides by 12. D equals 12 cosine 30 degrees. Plug that in my calculator, and I get D equals about 10.4 feet. So we labeled our sides. wrote our equation based on which parts of the triangle we have. Questions on that example? Right, so let's do that one. So I would do 12 times cosine 30, and I get 10.8. All right, let's look at another example. Here's our triangle for this one. And for this, we want to find x. And this is a 90 degree angle. So let's label our triangle. Is x the opposite, the adjacent, or the hypotenuse? It's the hypotenuse, longest side, across from the right angle. Is 8 the opposite or the adjacent side for this angle? Adjacent, it's next to?
Oh, yeah.
Yeah. So what ratio tells us about the adjacent and the hypotenuse? Cosine. So I'm going to say the cosine of 52 degrees equals 8 over x. Now how do I solve this equation? It's going to be my next step. Multiply by x. I want to get this x out of the denominator. So I'm going to multiply both sides by x. So I get x times cosine 52 degrees equals 8. Now how do I solve for x? How do I get that by itself? Divide by cosine 52 degrees. This is just a number. So I divide both sides by cosine of 52 degrees. So I get x equals 8 divided by the cosine of 52 degrees. And I would enter it in my calculator just like that. We do 8 divided by cosine 52, and I get 12.99. Label the triangles, decided which ratio to use, and then solve for what I needed, and then use my calculator. Questions on that example? So really the only difference between what we're doing today and what we did Friday is we have more choices as to which ratio to use. So the problem is not always going to tell you use tangent, or you'll have to figure out based on what you have which one to pick. All right, let's do one more. So here's our triangle for this one. And for this part, we want to find theta. So before we even do anything, what do we know that we're going to be using? Without even thinking of a ratio. We're finding an angle. So what do we have to use when we're finding an angle? Anybody remember? Find an angle. We have to use an inverse. So from the ratio, to whenever we're finding an angle, we have to use an inverse. So let's label our sides. 7, opposite, adjacent, or hypotenuse? It's the opposite side, it's across from the angle. 15, adjacent or hypotenuse? Hypotenuse. Always the longest side across from the 90-degree angles. So which ratio tells us about the opposite and the hypotenuse? Sine. So I'm going to say sine theta is 7 over 15. To find the angle from the ratio, I have to use an inverse. So theta is the inverse sine of 7 over 15. I can put it in my calculator just like this. So I would do inverse sine of 7 divided by 15, just like that, and I get 27.82. I could also do 7 divided by 15, get a decimal for that, 0.46666, and then put in the inverse sine of 0.46666. And I kept several decimal places, and I get 27.82, just like I did here. Oops. So when we're finding an angle, we have to use an inverse. Questions on that example? All right, let's go over the homework.